Okay, so let's go through the paper that you will have been looking at. Okay, so let's choose a colour pen, black. Right, so obviously you've written your surname, Waffy. Okay. So figure 1 shows two bar magnets suspended close to each other. Explain what is meant by the following statement. A non-contact force acts on each magnet. Okay, so quite simply, magnet A and magnet B, here they are. North and south are going to attract each other. They're pulling each other together, but they're not actually touching. So both experience a force, but there's no contact. Okay, so force experience, no contact. Describe how to plot a magnetic field pattern of a bar magnet. Right, 3 marks. Right, so you may have in class been given a bar magnet and you were told maybe put a piece of card over it and then get that little pepper shaker thing, yeah, filled with pepper. No, it's not pepper, is it? It was iron filings. Okay, so it's not pepper, it's iron filings, and then you could sprinkle that on top and you'd see the magnetic field. That's one way, but another way would be to have a magnet on a piece of paper, get a little plotting compass, and then you place it down there and the plotting compass is going to spin around until it's pointing towards the South Pole. So the plotting compass would probably look like this here, and if you put it here, the plotting compass would probably be pointing away, and if you put it here, the compass would probably be pointing this way. So essentially what you're going to do is you're going to take a plotting compass, place it near the magnet, remove it. So if I placed it here, right, I can see which way it's pointing, which way the field is pointing. I'd remove the plotting compass, and then I could put in the direction for the field at that point, and that is how I do it. And you'd need to make it, maybe try and put 3 bullet points so you get all 3 marking points. Okay, let's have a look at the next bit. A student has set up the apparatus shown in figure 2. The iron rod is fixed to the track and cannot move. The student gives the steel ball bearing a gentle push in the direction of the iron rod. At the same time, the student closes the switch. Explain the effect of the motion of the ball when the switch is closed. Right. Quite a few things going on here, okay? 4 marks, that's a lot of marks. So, it's a steel material. There are 3 naturally occurring magnetic materials, that is iron, nickel and cobalt. INC, iron, nickel and cobalt. And cobalt, I've probably spelt nickel wrong there. Nickel and cobalt. Now iron and steel are almost the same thing. Steel with an E. Iron and steel are nearly the same thing. Steel is a magnetic material as well. It is basically iron with a very small amount of carbon added. Iron, in fact, is a soft magnet. It's great for making the cores of electromagnets because it's very easily magnetized and demagnetized. But steel is a hard magnet. It's hard to magnetize and it's hard to demagnetize. It's good for making permanent magnets. Okay, but it is one of the magnetic materials. So the steel would be attracted to this magnet. Okay, so the student gives a steel ball bearing a gentle push in the direction of the iron rod. At the same time, the student closes the switch S. So I'd say that the ball would roll towards. I should really use capital letters. Keep your English good. Ball rolls towards the iron rod. As let's try and keep the grammar correct. My handwriting's terrible, so as the switch is closed, the coil and the iron rod become a magnet. The coil and the iron rod become a magnet, or become magnetic. Okay, so they become magnetic. This causes the steel to be attracted. Towards the iron rod, and speed up. Now I'm just thinking, exam technique wise, am I going to get 4 marks for what I've written here? I haven't checked the mark scheme yet, so I'll have a little pretend to be the examiner. This is exam technique. You need to be doing this type of stuff. If you want to, you can take a student with a potential of a grade C, and if they've got good exam technique, they can push their grade up by 1 or 2 whole grade boundaries by having good exam technique. So I'm looking at this and I'm thinking 4 marks. What potentially could I get a mark for? As the ball rolls towards the iron rod. Well, I'm just describing what the question's already describing. So really all of this here I don't think will get me a mark. But as the switch is closed, the coil and the iron rod become magnetic. Yes, I think I can get a mark for that. This causes the steel to be attracted towards the iron rod and speed up. Okay. I've really only said 3 things. Maybe I should try and add another point. So this could be me coming back to it after I've finished my paper and I want to check through. Okay, I can only really see 3 things worthy of a mark there. Maybe I get a mark for written communication here, but still I want to make sure I get all my marks. So I'm going to say the steel ball bearing becomes temporarily magnetic. So the steel becomes temporarily magnetic. Hopefully that would be enough to give me that final mark. Okay, so what I'm going to do now is just check the mark scheme. So you can see me checking the mark scheme as well. See that that's what I have to do to make sure that I'm doing a good job here. Magnets are not touching but experience a force. Yes, I think I'd get the mark for that. Here they talk about plotting compasses near the North and South Pole. Move the plotting compasses around. Join the points up and add an arrow pointing from north to south. Let's go back to my paper. Okay, let's go back to my paper. Did I mention, describe how to plot a compass? Oh, I didn't mention that afterwards you would draw in the field lines and then you would put in arrows to show the direction of the field. So actually I would have probably have got 2 out of 3 for my description for that bit. Okay, so lessons learnt. This is how we revise. Okay, do the exam paper, mark it carefully, be critical. Right, let's have a look at the 4 marking points awarded for this final question. So it was closing switch S causes a current in the coil. Magnetic field is created. A force of attraction acts on the ball bearing. The ball bearing accelerates towards the iron nail. Okay, so closing the switch causes a current in the coil is not something I've mentioned. Okay, so I'd probably again have got 3 out of the 4 here. Now, I'm not going to be too upset about the fact that I've lost 2 marks on this little section, because if I was to have gotten 7 out of the 9 marks available, I'm still well on track to getting a very high grade. But lessons learnt for next time. Closing the switch, because that's something else I could have talked about. Current flowing. Okay, so that is question 1 done. Thanks for watching.